Hi, in the previous lesson we talked about logic gates. Today we'll introduce binary operations, converting between decimal base 10 and binary base 2. Computers work with binary base 2, but humans usually use decimal base 10. Knowing how to convert is essential. From binary to decimal, write down the binary number assigned to the powers of 2 to each bit starting from the right, 2 to the power of 0, 2 to the power of right, and so forth. Then multiply each bit by its correct corresponding power of 2. And then we add the result. So, here is an example. In binary, 1011 will be in decimal 1 times 2 to the power of 3, 0 times 2 to the power of 2, plus 1 times 2 to the power of 1, and 1 times 2 to the power of 0, and then we make the sum. So 8 plus 0 plus 2 plus 1, so 11 in decimal. Now, the opposite, from decimal to binary. First we divide the decimal number by 2. Then we write down the remainder, 0 or 1. Then we divide the content by 2 and write down the remainder again. Repeat until the content is 0. The binary number is the remainder read from bottom to top. So, 13, how to turn it into binary from base 10. 13 divided by 2 is 6 with remainder 1. Then 6 divided by 2 is 3 with the remainder 0. Then we have 3 divided by 2, so 1 with remainder 1. And 1 divided by 2 is 0 with remainder 1. So, then, when we read it from the bottom up, we have 1, 1, 0, 1. Binary counting. Binary numbers increase the power of 2 from right to left. Here are the first binary numbers. So, 0 in base 10 would be still 0 in base 2. The same thing goes for 1. Then, we have base 2 because 1 plus 1 is 2. But 1 in binary plus 1 in binary, 1 plus 1 is 0. Then we have a carry, so 1, 0. Then we have 3, 1, 1, 4, 1, 0, 0, and so forth until 8, which is 1, 0, 0, 0. Okay, so how do we get from 7, which is interpreted in binary by 3 ones, to 8, which is interpreted by 1 and 3 zeros in binary? We start by adding to the right one digit 1. So 1 plus 1 is 0. We have a carry. 1 plus the carry 1 is still 0. And you have another carry. And the third digit 1 plus 1 is still a 0 with 1 carry. So we have 1, 0, 0, 0 at the end. And just how in decimal we move from tens to hundreds, in binary we move from 2s to 4s to 8s, and each new digit to the left doubles the value. Binary addition. Binary addition follows 4 basic rules. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 0 with 1 carry, which also resembles an XOR gate for the sum and an AND gate for the carry. Here is an example. 1011 plus 1101, we have 1 plus 1, which is 0, and 1 carry. 1 plus the carry 1 is 0 with another carry, and 0 plus 1 carry plus 1 is 0, and we have another carry, and 1 plus 1 plus 1 is 1 plus a carry, which we just write on the left side, and we have a final answer 11000. And just like how in decimal, you add digits column by column and carry V over when needed. Half adder. A half adder is a simple logic circuit that adds 2 single binary digits and it has 2 outputs. Sum, the result of the addition, which can be done by an XOR gate, and the carry, the overflow digit if both inputs are 1, which can be done by AND gate. And these are the two that have other uses, and you can see them on a picture here. This picture is taken from Geeks for Geeks. You can check their website, they have very useful information also there. Okay, now we move to full adder. A full adder adds 3 binary digits, 2 input bits and a carry in from the previous addition. It also has 2 outputs, sum and a carry out. They are essentials for performing multi-bit binary addition in processors. Here also this picture is taken from Geeks for Geeks. Link is also shown here, and you can also check their website to see the useful information they have there. Now, let's move to binary subtraction. Binary subtraction is similar to decimal subtraction, but it uses process called borrowing. Its basic rules are 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0, and 0 minus 1 is 1, and borrow 1 from the next column. Alternatively, the subtraction is often done using the 2's complement. Invert all the bits of the number you subtract. So if we make an adder a plus b, to make a subtractor we just invert b, add 1 carry in at the beginning of our adders, and we add that to the original number. This method lets computers use the same adder circuits for both addition and subtraction without the need for alternative solution, which there are. More complicated they are, yes, but still you can do it with different circuits. But it is very easy to use the 2's complement even in real life or simulation. Okay, we move to binary multiplication. Binary multiplication uses the same logic as decimal multiplication, but it is a lot simpler. 0 times 0, just like how in decimal, is still a 0. 0 by 1 is 0, and 1 by 0 is 0. So anything times 0 is 0, just like how I've already said in decimal, and 1 by 1 times 1 is 1. So here is an example. 101 times 11 is 101 because we 101 times 1, and 1010 times is the next, and then we add it, so we get 4 ones, 1111. And for the second multiplication, when we multiply the second one, we just shift it left how in like you do it in decimal. Binary division. Binary division is like a long division in decimal. Divide, multiply, subtract and break down the next bit. Repeat until done. Let's divide 1010 10 in decimal by 10, 2 in decimal. So we should get 5. So, step 1. How many times does 10 go into the first 2 digits of 1010, which is 10? 10 goes 10 into 10 exactly once, so we write 1 above the line. Then we subtract the 10 from 10 to get 0. Bring down the next digit. Step 2. Bring down the next digit 1, and now we have 0, 1. 10 does not go into 0, 1, so we write 0 above. Bring down the next digit 0. Now we have 10 again. Step 3. 10 goes exactly into 10 exactly once, so we write 1 above, 101. And final answer, 10 0 10 0 divided by 10 is 101, which means the 10 divided by 2 is 5 in decimal, and 1010 divided by 10 is 101 in binary. Binary division is used in arithmetic logic circuits ALUs and supports operations like modulus and quotient calculations. Summary. Binary is the language of computers. Understanding how binary operations like addition, subtraction, multiplication, and division work is essential for learning how computers process data. Logic circuits like half-adders and full-adders are used to build arithmetic units inside CPUs. With just ones and zeros, computer can perform almost anything from basic math to complex calculations to the things your computer does. If you enjoyed the video, please hit like, subscribe, share, follow on Instagram, and watch the next video if it's already out. See ya, bye!